Hey everyone, Chang here and welcome to my channel. Now today's video I'm going to focus on this right here. This is the equation for an ellipsis. So now here's the thing. I was trying to figure out what is the best way to sort of tie everything together. Remember that we have this whole chain going on. We have Pythagorean theorem leads to distance formula leads to circle formula, and now circle formula I was trying to figure out how to tie it into the formula of an ellipsis. From what I can see, a lot of the time on the internet, the best way they explain the formula for ellipses, they actually use the concept of foci or focus, depending the focus points. And I feel like those are amazing and I'm gonna save it for a future video, but I wanted to tie more closely into the concept of a circle because, well, circle is a lot easier and we can see circle and ellipses relating very well, just at least visually. So hopefully this makes a little more sense. Now, here's the equation and let's just talk about all these different variables. First and foremost, it looks very similar to the equation of a circle. So you would have x minus h squared plus y minus k squared equals r squared. Right? So that's the equation of a circle, where h and k is your center. Okay? So, this is the equation of a circle. Let's just put it right here, circle. And this is ellipses. Right? Now, here's the thing. Notice the similarities, right? The only difference is that we have 1 here and we have a squared and b squared at the bottom. Now I chose a squared and b squared. I've seen a lot of different variables that they use down here, but I'm going to explain to you what they are basically. So the center is still the same. H and k, I'm going to stick with h and k. A and b is talking about what they call the major and minor axis. I don't like the fact that they're talking about major and minor axis because, I mean, it depends on how big or how small that is. The whole point of an ellipsis is that it looks like this, or if you flip it over horizontally, it looks like that, right? Either way, there's this what they call major axis, which is the larger portion, and then the minor axis, which is a smaller portion. Here, the minor axis is right here, horizontally, and the major axis is actually vertically. So it depends on the orientation of the ellipsis itself. Now, A, basically, I think it's easier this way to remember. It's just talking about the stretch of the x coordinate. So let's just say this right here is A. So this whole thing is going to be 2A. Here would still be A. So rather than calling it just major and minor axis, I would say A, where you see it's under the x, the best way to remember it is that whatever variable is under, that's the one it's affecting. So you can guess with the B, it's under y, so that would be affecting the y stretch. So this would be B, or in this case, what they call the major axis would be B on this one right here. So that's what each and every one of these variables come from. So now I'm going to try to see if this works. Hopefully it will. I'm going to use the equation of a circle, the formula of a circle, and try to relate and see how that comes to become the equation or the formula of an ellipse. So let's look at that. Alright, so let's just start off with giving a lot of information. First and foremost, I'm going to start off with this. We have x prime and y prime. Now, here's the thing. If you haven't seen prime before, it's slightly different. It looks like it's to the 1 power, but it's not. This is not a number, and that's just because my poor penmanship, it looks like a number. You will encounter in the future, or just in your math studies in general, certain textbooks, certain, I guess you could say, blogs or internet posts, or just, I guess, documents in general. If they have two variables that are very closely related somehow, and it depends on the context of that specific problem, but if they're closely related somehow, they would usually use one of them as just a regular letter and the other one as a prime, just to indicate that they're closely related. So that's what I'm going to do. Now, with x prime and y prime, that means you guys can guess it's very closely related to x and y. I'm going to say x prime squared plus y prime squared equals 1. Now, from this, hopefully you guys can tell, this is basically the equation of a circle where you have basically one of your variable, the other variable, related to x and y, and the radius itself is 1. So this center is going to be 0, 0, and it's going to be 1. Okay, let's just do c equals 1, make it more clear. All right, so at first, I mentioned that ellipses and circle are very closely related. Circle is that the distance itself is all the same from that single center point, right? That's what the radius is. Ellipses still has a center point, except for, I guess you could say, it looks like a circle where you stretch one side more than the other. So for example, if we want an ellipsis right here, where instead of it being a circle, you stretch everything here by 3 and everything here by 2. Right? So everything is stretched 3 horizontally, 2 vertically. That's your ellipsis. So what can we do? Well, if we're going to stretch it, this is what's going to happen. Remember, numbers can't just come out of thin air, right? Whatever you do, it has to make logical sense, or it's going to ruin the whole equation. So x prime squared is now going to be, if I wanted to stretch it by 3, it's going to be 3x prime squared over 3 squared, which makes sense, right? Because 3 squared, right, and x1 prime squared over 3 squared, the 3 squared would technically cancel out if you want to simplify. It's just 1, so you're allowed to do that. Same with the concept of y. So I'm going to have 2y prime squared over 2 squared. All right, cool. Now, why would I do that? Well, this is to stretch out this the circle into an ellipsis, right? We're going to stretch out the x by 3 and the y by 2. Now, this doesn't look like it's all that useful, and here's where it gets a little interesting and a little tricky at the same time. What I'm going to do is, instead of have it as 3x prime, I'm going to say x equals 3x prime. This guarantees that for whatever x I'm choosing, it's going to be stretched by 3. Right? And y, you can guess, is going to be 2x prime. So whatever y we're choosing, whatever coordinate it is, right, point it is, it's going to be stretched by 2. And therefore this thing, well, let's just remember that it still equals 1. This thing changes to become x squared over 3 squared plus y squared over 2 squared, squared, equals 1. And there you go. This looks very close to the concept or the formula of an ellipse, except for this one it's more specified. We have our 3, which we chose to like stretch out by 3, and then we have our 2, which we also chose to stretch out the y coordinates by 2. And just like that, we have our x squared plus y squared, where x squared is going to be over 3 squared. This is going to tell us our x stretch. Y squared over whatever down here is, which is going to be 2 squared, tells us our y stretch, and is still equal to 1. So this I found as a sort of not the best, but hopefully a better explanation on how circle and ellipses are related in terms of the formula itself. Once again, a lot of the ones I looked at is focused on the foci points, and which is great. But I wanted to relate this more closely to a circle instead of foci point. We will talk about focal point in the, I guess, future video. All right, so I just erased everything, cleaned it up a bit. But basically, we had this formula right here, or this equation right here, to represent basically this ellipsis. But we can generalize it. Instead of just stretching for 3 and stretching for 2, what happens if we stretch it for some arbitrary number and some arbitrary number? That's where that general formula came in. Instead of 3, we can say, well, I mean, we can say 4, we can say 5, we can say whatever. We're going to call this A, right? And then there are other renditions of this formula might use a different variable, but basically, I'm going to call this A. They can call it whatever, but understand that once again, if it's under X, it's just talking about in the X coordinates, right? And then this one we can call B in this case, which is going to be a Y coordinate. So instead of 3 and 2, we can rewrite this as X squared, and this is going to be A squared plus Y squared, and the bottom is going to be B squared right here, equals 1. And lastly, to wrap it all up to make sure that it is as general as possible, remember that the x and k, just like the circle, actually almost exactly like the circle, when we wanted to find and shift the center, we're just going to do the same thing here. So it's just going to be x, just to make sure it's obvious right here, it's going to be a minus h squared over a squared plus y minus k squared over b squared equals 1. And just like that, this right here, this shifts the x and shift the y, basically center point, right? So hence this is your center, your regular, x and y, and then your major minor axis, whatever you want to call it. Basically, stretch an x coordinate, stretch an y coordinate, right? And this is your generalized formula for an ellipse. All right, so let's look at this first problem. Now, this one was an interesting problem that I found. It says, what is the equation of ellipse with x radius and y radius? Now, that is a new name for me, but I mean, it makes sense, right? There's always different names for the same thing in math, right? Major axis, minor axis, or in this case, I called it the x and y stretch. And the x radius or y radius actually works. I actually really like it, right? That's probably what I'm going to use from now on. Let's just call it the x radius and y radius. Now, the equation is fairly simple. We have our x radius at 6, y radius at 9, and it's located at the origin itself. So we know that it's going to be x squared and y squared. There's no h or k because it's located at the origin, and the hint of origin, or the key of origin, is the fact that it's located in 0, 0. So there we have that. Now, cool. Well, if we're talking about the x radius, meaning that, I guess they mean the x stretch, and we know that it's 6, then that means we want it to be 6 squared right here. The y radius is 9, so that's just going to be 9 squared right here. Of course, we're adding, and that's going to be equal to 1. And just like that, you have your equation of an ellipsis. Now, here's the thing though. Sometimes this is not enough. This is what we call standard form. And of course we love standard form. I love standard form. It tells us exactly, or it gives us a visual of what the ellipses look like. But there are certain cases where they don't like it like this, so you just got to be careful. Some of them will require you to basically multiply everything out, which would be x squared plus, or x squared over 36 plus y squared over 81 equals 1. And some of them would go even further, as you want to get rid of all the denominators. So pay attention to the context of the problem and what they're asking. So let's look at the second problem. Very similar to the first, slightly more challenging, because guess what? Now we have an actual location, right, for the center point. It's -7, 10. But other than that, is asking the exact same thing. What is the equation of an ellipse with x radius 2 and y radius 5? So let's do that. All right, well, we have our x and y. We have our center. So for the x coordinate of a center is -7. Now, don't forget, in the generalized form, right, it's always a minus h and a minus k. Well, if this is a -7 or a -7 array, so minus minus is actually a plus. So that's actually +7 right here. Got to make sure we square that. And for the y, standard, because it's a +10, it's going to be subtract 10, and this is going to be squared. That already gives us a lot of information. All right, well, what else? We have our x radius, which is going to be 2 squared, because whatever the radius is, we're going to square it, right, at the bottom. And this one here is going to be 5 squared. Don't forget, we're adding these guys, and in the end, it always equals to 1. And that's the thing. It always equals to 1, and that's why I wanted to relate it to basically the original circle equation with x prime plus y prime equals 1, with basically a circle xy with 1 as radius. But here we go. Anyways, I digress. So we have this. Normally you're done. If not, make sure that you follow through with the instruction. That might mean this equals 4, this equals 25, or it might mean that you have to multiply everything by 4 to get rid of the denominator of 4, and make sure you do it on both sides. And same with 25. You'll have to multiply everything by 25 and on the other side, and that gets rid of the entire denominator, and you would have this crazy and ugly looking equation. So I'm going to show you one of these in the next problem, and we're going to go backwards. So let's work on that. Alright, so here's our problem, and this is a doozy of a problem. Now here's the thing. This is an equation of an ellipse, alright, just to let you guys know. And as I mentioned previously, sometimes, you know, whatever, based on the context of the problem, they might want you to simplify the problem all the way until it looks like this. I don't think it's helpful in any way. I mean, looking at it, it doesn't even look nice. I don't know why, but, you know, some textbooks, some problems just want you to do that for the sake of torturing you guys. So, there we go. Now this one is different. If they want you to sketch this one, you actually have to go backwards and try to write it in standard form, because only with standard form can we truly understand basically what the ellipse look like. Well, let's just start off with this. We have 25x squared plus 9y squared minus 200x plus 18y plus 184 equals 0. Well, I'm going to get rid of the 184 first. Okay. What I do to one side, I must do to the other, so I can't just, you know, start removing numbers for no reason. And so what we have now is going to be 25x squared plus 9y squared minus 200x plus 18y equals negative 184. There we go. Cool. Now, I'm going to rearrange this, and you're going to see why in a minute. 25x squared minus 200x plus 9y squared plus 18y equals negative 184. Right, I just rearranged the x and y together because guess what? I can start factoring stuff out. And I'm going to start doing something a little weird, but follow along and you're going to see what's happening. So I'm going to factor out 25, right? And what I have is going to be x squared minus, what is that? 8x. There we go. Okay, and this one, I'm going to factor out the 9, so hopefully you guys can see it. The 25, that's where I got it, and 9, that's where I got it. And this one is nice. Some of them are not so nice, just be a little careful of that. But here we are. We have not y squared plus 2y equals negative 184. And there's a reason for that, because guess what? I want this one to be x something and squared on the outside. Right now, that's not the case. So hopefully this is screaming at you. If not, that's entirely fine. What I'm going to do is I'm going to do completing the square for this one, so I can break this down into its actual like big factor, and completing the square for this one as well, and then add, you know, those added numbers into the other side so you guys can see. All right, x squared minus 8x. And so if you guys aren't familiar with completing the square, you usually get whatever's the coefficient in front of the one that is a single exponent, the variable with a single exponent, and then you divide it by 2 and times itself, right? So in this case, what do we have? Negative 8 divided by 2, negative 4 times itself, 16, right? So that's going to be 16. But here's the thing. If I'm going to add 16, I'm not actually just adding 16. So what it's going to look like is going to be 25 x squared minus 8x plus 16, right? That's what I'm hoping for. Well, I'm not really adding 16. I'm adding 25 times 16. So on the other side, I got to make sure I add 25 times 16. Okay, so just don't lose track. The other one, same thing, is going to be plus 9y squared plus 2y. 2 divided by 2 is 1, times itself is 1, plus 1 right here. That's going to equal to whatever this is, but since I'm adding a 1, technically, well, 9 times 1, I have to make sure I add 9 times 1 right here. All right, cool. So basically, negative 184 and 25 times 16 is what? 400 plus 400, right? Plus 9. There we go. Cool. All right. And then this one, now we can actually complete it, which is going to be 25. It's going to be x minus 4 squared plus 9 times, this is going to be y plus 1 squared equals, what is that very quickly? I think 225. I could be wrong. Double check my math. Right? I think it's 225. Yeah. Okay, cool. Now, we're getting there. We're almost there, right? We got this part, which is great. That's what we really want. That's what I've been working towards this whole time. So all this like long, tedious looking math is just to get to this part. And then afterwards, what we're gonna do, and I'm gonna do this. We're gonna divide everything by 25 and by 9. I'm just jumping steps at this point because I'm running out of room. Divide by 25 and 9. Right? So, what does that do? Well, what it does is basically it gets rid of the numbers in front of the parentheses. So, here, it's going to be, 25 is going to go away, but the 9 is going to stay at the bottom. So what we have is going to be right here, x minus 4 squared over 9. And this one, the 9 goes away, but 25 stays at the bottom. It's going to be plus plus 1 squared over 25. And this one is what? Well, this one first and foremost is going to be 6. And it's going to be times 9 is, well, 6 over 9, right? Let's see, 25 goes in here, no, not, what am I talking about? Not 6 over 9, 9 over 9. I'm going crazy. 9 over 9. There we go. I thought it was kind of weird. All right, cool. So 9 over 9, that's just 1. So let's see, I'm gonna just erase this part. I need a bigger board. All right, cool. So let's do this. Right here we have x minus 4 squared over 9 plus y plus 1 squared over 25 equals 1. All right, cool. This one right here, it's just 3 squared. This one right here is just 5 squared. And voila. Just like that, we have our equation of an ellipsis. We have all the information we need. I'm not going to actually sketch it, but I mean, we can if we really wanted to, right? Because guess what? Our center is going to be 4, comma, negative 1. Remember, this is a plus, which is supposed to be minus minus, right? So that's going to be negative 1. That's our center. That should look like a better C, right? And then we have our x radius. It's just going to be 3, and our y radius is going to be 5. And just like that, we have all the information we need to make a sketch of an ellipsis. Whew. All right, so we're at the end of the video, and now here's the thing. Once again, I'm hoping that it is not as confusing as it might have initially seemed. We use a circle with radius 1, and realize that if we were to stretch it along the x coordinates, or in this case I would love to call the x radius, and along the y coordinate or the y radius, we get an ellipse. So with that understanding and little number finagling, we get the general formula of the ellipse. Now when you're encountering problems, at least basic problems of ellipses, you're going to encounter mainly they're going to ask you for creating a formula. They give you the required information and then you create the formula, which is what we did. And of course, make sure you simplify it as necessary. But the scary ones are something like this. And this one, you got to be careful because it always requires you to use other scales. So in this case, what we did is we reorganized everything and realized that we actually had to do completing the square, right, to get the actual, I guess you could say, factored here and here to get the center. So this actually takes practice. It takes experience. It's really difficult for someone to just look at it and know immediately. So don't get discouraged if that's the case. Just look up more of these problems, practice it, and eventually you're going to be such a boss with ellipses. Thank you for watching this video. Hope it helps. See you in the next one.